Hi, welcome back. We're doing another installment of the walkthrough video of the Budget-Beater Electrathon car. This time I want to get into the motor and the battery and the drive wheel. This is kind of the interesting part of this project. The motor specifically is a 40 volt Ryobi brushless motor from a push mower. Those new battery operated push mowers they have. I always wanted to do something with one of those motors, not necessarily the Ryobi, but one of the electric mowers, just because they're now, mass produced. There's a bunch of them out there. You can pick them up cheap, broken, or wore out, or no battery, or whatever. And traditionally, it's always been the expensive part of Electrathon, getting a motor specifically. The other motors out there that people are using tend to run minimum of $400 to $500, and you can go way up from there. But finding something cheap is rare. This one was used because I didn't buy it on a new mower, but I got it off of eBay for $45 with shipping, which is about, again, a tenth the cost of what a new conventional Electrathon motor would cost you. And it worked out pretty good. I was pretty happy with it. It is a little small. It's only, I don't know, 4 or so inches in diameter. You can't see it very well here due to the motor mount, but I didn't want to take the whole thing off. I'll have some pictures at the end of the video showing one disassembled, give you a better sense of the scale. But I mounted this one when I first got it. I mounted it in my other car just to see if it was at all viable. Instead of trying to build a whole car around it, let's put it in something that already exists. So I ran it in the other car on 36 volts lead acid. And I ran around the neighborhood and it went pretty well. Definitely didn't have as much power as the motor I normally run in that car, but it seemed to do the job. But because it was a little underpowered, it pushed this build in the direction of running lithium, because lithium, you on average are carrying at least 50 less pounds of weight than the corresponding lead acid pack would be. And I figured the little motor needed the help. But anyway, yeah, $45 on eBay. The tricky part was it has a 13 millimeter shaft, which is not standard for trying to put any sort of sprocket on. A 13 millimeter bore sprocket is hard to come by. So I ground it down to a 1/2 inch and I slotted it for a keyway with a Dremel tool. I have videos of both of those things available on this channel. Just back up a bit. I believe I entitled it Turning Down a Motor Shaft the Wrong Way. And then the other one is something about a key slot with a Dremel tool. You'll find them. They're on there. I did it without conventional machine tools. I did it with a drill press and a grinding wheel, and it came out really well, actually. It runs nice and true. I was pretty pleased with the whole thing. So I got it down to a 1/2 inch shaft so I could put a conventional sprocket on it. I'm running a number 35 chain with the appropriate sprockets. One of the things about this motor, though, is it makes about 100 RPM per volt, which on a pack, we'll get to the pack in a minute, but this pack is a 48 volt nominal pack. So we're talking about spinning about 5,000 RPM, which is pretty fast. So that became an issue later when it came to gearing the thing appropriately, but we'll get to that too. You can probably see through here the fins on it. Those cooling fins are, they're not stock. The motor doesn't come with those. I bought a set of cooling fins off of eBay and had to cut them down to fit, but the motor likes to run a little warm because, of course, it's working hard. It's a little motor moving. This thing was probably 300 pounds with the driver anyway, something like that. So, a little motor working pretty hard to do it. But on the whole, I was very happy with it. I mean, a $45 motor, it was pretty cool. I was pleased. It helped keep the cost down. it was actually that the thought of being able to use that motor that kind of prompted this whole build, because that started raising the question of, well, if you could use a $45 motor, how cheap can you do this whole project? And that's what we found out. The controller I used to run it, let's see, not a very good angle there. Not a very good angle there. Whatever. We're going to go with that. This controller is a 1500 watt e-bike controller off of eBay. It cost about $37, $38. Again, cheap, cheap, cheap. But that was the point. It will run 36 or 48 volt. It has really no notable features that I could determine. There was not a lot of description that came with it, with any sort of documentation, because I don't believe there was any documentation. And its description on eBay was pretty minimal. Matter of fact, I was so suspicious of it, I bought 2 of them and brought another one with me to the race event, anticipating having to swap it out, but I never did. It held up. 1500 watts is kind of what I would consider the bare minimum for this, but it was the only thing available. You want higher wattage e-bike controllers cheap. They generally need to go higher voltage to keep the amperage low. But it worked out well. Just a cheapy e-bike controller, not a lot to it. The battery I ended up using is, I don't know how well you can see that tag. It is by BTR, whatever that means. It sounds like battery. BTR Power, off of eBay. 48 volt nominal voltage, 20 amp hour capacity. That's about all it says. In the description on eBay, they said it was a 16S lithium. Now, when I say lithium, this one is a lithium iron phosphate, one of the less volatile chemistries of lithium battery out there. In Electrathon, if you're going to run lithium iron phosphate, I believe you're limited to, of course, 1 kilowatt hour, which the 48 volt 20 amp hour brings us up to about 960 watt hours, so we're fine there. But you're limited to, I believe it's like 27, 29 pounds of weight. You have to check the handbook on that one. 29, I believe. And this is under that, so we're fine. The interesting thing about this, though, is since it is a 16S, or 16 cells in series, this gives this a maximum voltage of 57.6 volts and a minimum voltage of 40 volts. So they average that out and they call it a 48 volt battery. Okay, so now if we remember that the motor wants to run 100 RPM per volt, when we're at the top voltage of 57.6, which it doesn't actually hold that, you put a load on it, it drops down to about 54 right off the bat. But okay, we'll call it 54. Then we're turning 5,400 RPM thereabouts, which is really spinning, which then made the gear ratio interesting to try to get right on this. So I wasn't running this crazy high speed, because the lower you can gear the motor, the cooler it will run, the fewer amps it will tend to draw. There's only so much torque available, especially out of a small diameter motor like this. But we'll get to the gear ratio in a minute. But it all kind of went together. The fact that I chose that motor made a lot of the other decisions for me. It meant I had to go with lithium chemistry, or I felt I did, because I need to keep the weight down as low as possible. It allowed me to run a higher voltage, which is good because in lithium, running 36 volt lithium is harder to do. Most lithium chemistries and most packs out there right now are geared towards e-bikes and whatever else, so they tend to run higher voltages than what is commonly found in Electrathon. There's nothing saying you can't run 60 or 72 or 84 volts in Electrathon. The rules are wide open for that, but it isn't generally done. But anyway, also choosing this battery, as it was on sale on eBay, they did their 5% off or whatever it was. This was just under $300, $298 with a 5 amp charger as well. Okay, great. Because ideally I'd be able to charge it between races, and then I wouldn't have to buy 6 lead acid batteries to get through 2 races in one day. I could just recharge this one in between. I couldn't do it with just the 5 amp charger, had to get something bigger, but we'll get to that in a minute. So this, the battery allowed me to save some money too. Since then it's gone up. I believe now it's $320 for the same battery on eBay. But when it came time to recharge it, I noticed that it would get hot. This, what you're seeing here, this heat sink, is not the way it came stock. There was originally just a piece of reddish brown fiberboard cover over it, whatever, which ended up covering up the battery management system that sits right here. When I went to charge it, I noticed that the top of the battery would get hot. At the time, I didn't know what was under there. I mean, it was a sealed magic box to me. But it would get hot. And it was concerning. I thought maybe I had a problem with a cell or something else. So after a lot of debate back and forth, both online and internally, I decided to take the top off and take a look at it. And there is a series of MOSFETs type of transistor in here that is used for the control of the power, both for charging and for discharging. And the one that seemed to be responsible for charging, I said it because it was the only time it got hot, was when it was charging, was getting very hot. However, looking up the spec on that, it was within spec for what that component could take for heat, but still it was disconcerting. At one point, it was 165 degrees Fahrenheit on the outside of the fiberboard. That just seemed way too hot. So I took it off, and they had, underneath that fiberboard, there was just a flat aluminum plate to work as a heat sink. I didn't think that was sufficient. I bought this heat sink off of Amazon, cut it to fit, did away with the fiberboard. This is finned instead of just being a flat plate. And I used thermal paste on there for heat transfer. And when I charge it, I run a small fan, just regular household fan. I point at it to blow across it, and it seems to control the heat really well now. It's fine. So it did take a little bit of tweaking on that to get it right. Now, this battery came with, of course, it came with a charger, and it came with a plug that you had to add to it for charging. But the 5 amp charger was not going to be sufficient to charge the battery between races in that 2.5 hours. A higher amperage charger was going to be considerably more money, and it was kind of pushing me outside where I wanted to go budget-wise. So I went with an alternative route, and I bought another cheap, it was supposed to be 4 amp charger off of eBay, and I wired its plug in as well in parallel. So now I have 2 very different types of plugs, but wired into the same charging leads. So I'm running a 5 amp charger and a 4 amp charger in parallel. I'm sure somebody's going to have issue with that somewhere when they see this, but it did work. I actually didn't have any problem. I checked it with my multimeter. I put it in series on amperage, and a 5 amp charger and a 4 amp charger together for some reason equals 8.6 amps. I guess their tolerances on their ratings aren't so good. But either way, so I charged it on 8.6 amps between races. Now, overnight, since the race event I went to was 3 days, I only had to do a fast charge like that once per day. At the end of the day, so it would be charged for the next day, I would charge it at a lower rate. Generally, the 4 amp charger was the lowest rate available to me. It would take, of course, quite a bit more time, but I didn't generate a lot of heat or anything else, and it all worked out okay. But anyway, yeah, BTR Power, 48 volt, 20 amp hour battery pack off of eBay. It will not look like this when you get it due to my add-on heatsink. Checking the capacity of this thing, you can see that big fan back there behind me. It's a 48-inch fan. I got that off of Craigslist. It needed a motor, and I bought it just because I wanted to be able to load test this battery. And load testing 48 volts is a little more complicated than load testing a single 12-volt lead-acid battery. There's a lot of stuff out there for a 12-volt load. There's less stuff available for a 48-volt load. What I ended up doing was I took this motor and that controller and this battery and I hooked it all up on that fan. So I had a 48-volt DC-powered fan. And I would run it. I could set the speed with the throttle. I'd run it so it was pulling about 1,200 watts. And I just let it run, see how long it would run for. And I had a meter hooked up to it. And when I first cycled this battery the first time, I only got 18 amp hours out of it when it's supposed to be a 20 amp hour battery. Not great. It also cut off at like 48 volts instead of going down to what should have been 40 volts. So that tells me that probably the cells were not balanced very well, because the battery management system is supposed to cut it off when any single cell drops below a certain threshold. It tries to keep everything balanced. That's its whole point. So I only got 18 amp hours out of it the first time. So I charged up, tried it again. Second time I got 18.8 amp hours out of it. Okay, so I cycled it again. This time I got like 20. Before it was all said and done, I was getting 21.5 amp hours out of it on the 5th cycle of it, which is, of course, above spec, which is nice. And as Electrathon goes by manufacturer's nominal specifications, which in this case, 48 volts, 20 amp hours, that would be 960 watt hours. That's what they go by. So while this pack was actually performing above that spec, I'm still legal, which is nice. Never did manage to totally discharge this pack during competition. We just didn't push the car hard enough. We were honestly afraid something was going to break, and we didn't want to go all the way down to Fort Myers and pay all the money for the U-Haul and everything, to cart everything down there just to blow the car up and then not get to run it very much. So we didn't push it that hard in the beginning. As it turns out, we never pushed it hard enough to deplete the pack. So there's more performance in the pack, more performance in the car than we were really aware of. Than we're still aware of. We still don't know what the limit is. But anyway, so the pack was a good deal for the money. Decent performance, can't complain. It was a little weird having to modify the BMS cooling, but it worked out. May not be for everybody, but it's worth looking into anyway. Now, the wheel back here is a one-piece aluminum wheel off of eBay. They have a million listings for them. They range in price from about $57 to some people are charging $70. So you know how eBay is. The same thing goes for a wide range of prices. I paid the $57, of course. It's a decent wheel. It runs nice and straight. I was very happy with that. It is threaded for a freewheel on both sides. Only has a 10 millimeter axle, which is the smallest allowable axle in Electrathon anyway. I would have liked to have used a wheel like this on the front, but they didn't have anything with provision for disc brakes, and I would have had to change the bearings out because a 10 millimeter axle is too small for a front axle if it's only going to be supported on one end. 10 millimeters is only allowable if it's supported on both sides, like it is in a rear wheel application like this. Still, I was very happy with it. It seems like a pretty decent wheel for the money. I like the fact that it's solid. I don't care for conventional bike spokes. They're always breaking or loosening up and requiring tightening, and then you can get your wheel out of true. I like this option better. It is running what I consider to be the preferred Electrathon tire, in my opinion, which is a Maxxis hookworm, which is capable of 110 psi of pressure. I run mine around 80 just because it gives a little more give, and if it's really hot on the track, you don't need ambient temperature driving the pressure up really high where it could blow a tube. But I like the Maxxis hookworm. They have low rolling resistance. They have really good grip. They've got plenty of rubber, so there's a lot you can get a lot of miles on it before you wear them out, assuming you've got a good alignment. All that was fine and good. The freewheel you can't see from here, and I didn't take the wheel off, but the freewheel, of course, threads onto the threads of the wheel and is a one-way clutch. It allows you to coast without driving the motor. I used about the cheapest one I could find on eBay. I want to say it was like $10 or $11. It was so cheap, I got nervous and I bought another one of those too, just because I thought it would probably break. And it didn't. That being said, on my other car, I use a freewheel from sickbikeparts.com, which is their heavy-duty freewheel. It's like $80 or $90, so it's way more money, but it is extremely rugged. Because if you know anything about freewheels and the fact they thread onto the wheel, a lot of times they don't want to come off again. So if you break one, you have to take it off. It can be a real problem. And if it breaks during a race, there's very little chance you're going to be able to swap it fast enough to get back in the race. So you're essentially probably losing the race right there just because you had to pit with a broken freewheel. But anyway, it did hold up. So I have another $10 freewheel laying around here that I haven't used for anything. Getting back to the motor and its RPM per volt being around 100. So if this thing, under initial load, the battery's providing 54 volts, the motor's making 100 RPM per volt, we're spinning 5,400 RPM, which made the rear sprocket a little more difficult. 60 tooth rear sprockets are easy to find. 70 tooth rear sprockets are harder to find. 84 tooth rear sprockets are even harder to find. And I really wanted an 84 because if you use a gear ratio calculator, I'll try to link in the description the one I like to use. You can input motor RPM, number of teeth on the motor sprocket, number of teeth on the drive sprocket, and or driven sprocket, and the overall diameter of the rear wheel. It will give you your calculated speed. And I always like to gear my speed so it is only a couple miles per hour faster than the average speed that I'm shooting for that particular track. You can gear higher, but then your chances are you're going to be drawing more amperage on acceleration, and your acceleration would likely be slower. So I like to gear pretty close to that. Everyone has their own preferences. Do as you see fit. It doesn't matter. But an 84 tooth rear sprocket is harder to find. I lucked into this one. Good luck finding one as cheap as I did. This one was, I think, $20-something. That's the downside of using this motor and that battery, is that you're going to have such high RPM, and you can't go much smaller than this. This is a 10 tooth sprocket here. It's about the smallest you can find for a half-inch shaft. Maybe you might be able to find a 9 or something. But if you play with the gear ratio calculator, you'll see what I mean about the differences made by the gearing. It's easier to go with a large gear in the back and then change your motor sprockets out for different tracks, for different speeds desired. That's what I always do, because motor sprockets tend to be a lot cheaper than rear wheel sprockets, and they're also a lot easier to change. Take off set screw, slide it off, slide a new one on, put your chain back on, and you're done. You can do it in a matter of minutes between races instead of having to pull the wheel off. And again, rear sprockets are harder to come by. So you'll have to make your gearing selection carefully. But yeah, that was kind of the heart of this, was that motor, that battery, and a cheapy e-bike controller. I was surprised and pleased with how well the whole thing worked out. The battery was the single most expensive component of this build at almost $300. By the way, that second charger I bought, I want to say it was like $45 or $48. But anyway, the second most expensive item, oddly enough, was the aluminum sheet that I used for the belly pan. I paid $80, but it was like a 4-foot by 10-foot sheet. So I had more than enough to do this. I have plenty left over. It's also what I made the nose out of up there. because I didn't want that to be the coroplast like I used for the rest of it, because my feet push against it, or the driver's feet push against it periodically, and you don't want to just go pushing the nose off the car. So aluminum up there as well. Now, $80 was cheap for this stuff. I got it at a local metal supply company, but they have a scratch and dent bin where if the forklift driver screws up and stabs a sheet and bends it, or this one I think just had a water stain on it where it sat and got wet and it stained it, it went in their scratch and dent pile, and I got it at like half cost. So $80, well, it sounds expensive. I have enough left over. I could do 2 more cars just like this, but yet I attributed the entire cost to this build. So if you have a local metal supply place, ask them if they have a scratch and dent bin or whatever, and because there's no reason you have to have really pretty metal to put on the bottom of the car. It's not that important. This is 50 thousandths thick aluminum. It's about as thin as I would want to go, but the car is narrow. There's a lot of cross ties. It's riveted up through into all the cross ties and the side rails, and it holds up fine. It's generally how I do my belly pans on the cars. Again, the sides are coroplast, which is corrugated plastic, like corrugated cardboard, but plastic, the stuff that they make political signs and real estate signs and stuff out of. I got that at Home Depot. It was like $28 for a 4x8 sheet. If you're really careful and your car is this size, 1 sheet should do it. Of course, your car is smaller, it'll go farther. If your car is larger, you may have to buy a 2nd sheet. But it's lightweight. It takes paint fairly well. You can hold the body on with zip ties, which you may be able to see across over there how the various zip ties are. And I run tape over the seams, which I had to cut to get this panel back off. But yeah, that's the basis of this build. If you have any questions on something I didn't cover, post it in the comments. I'll either answer in a comment, or if it's significant enough and involved enough, then I'll perhaps do another video on it. If you're interested in having this car donated to your organization after I put it back together, watch the first video in this series that talks about how you can make that happen. I'm not looking to keep this car. I'm willing to donate it to a new team starting out that doesn't have a car yet, that wants to get into Electrathon. You have to make arrangements to come get it yourself from the Pensacola area. Again, go back, watch the first video. It covers all that. Yeah, I look forward to any questions and comments. Hit me up.